Hello, I'm Alan Keays from the Rutland Herald, and I'm joined today by Polly Lynn from the Mountain Times. And our guest today on Insight is Dr. Alan Betts. Dr. Alan Betts is has atmospheric research in Pittsburgh, runs that group, and he is a Vermont's leading climate scientist. He's a frequent speaker on climate change issues around the state, and he is co-chair of the cross-cutting working group of the Vermont Climate Collaborative. We're here to talk about climate change and what's been going on with the weather lately. We had a big weather event here just last week. The hailstorm came across as a tornado warning that a lot of people received on their cell phones now from the National Weather Service. I know the warning that I got said, please take cover. Pretty extreme stuff for us here in now, exactly, the now part, with an exclamation point, and it was in all caps as well. What's going on with the weather?
Well, if you go to the Weather Service and talk to them about the weather of the last 5 years, they'll say there's been a lot of weather situations that they have never seen in the last 10, 20 years. Mm-hmm. I mean, we've seen lots of more severe thunderstorms, and that particular hailstorm last week was an example of this. The type of storm that is common out in Oklahoma, but I think we haven't had a hailstorm with as big golf ball size hail for maybe 30 years in Rutland. So it's a shock, and it really is changing. I mean, I think the best quote was from Jeff Wenberg, Commissioner of Public Works in Rutland, the next day when he said, in 6 years we've had 6 storms that they said were 10-year storms or 100-year storms, and we're getting them every year. We just we don't have the infrastructure. Our infrastructure was not built for that kind of severe weather and severe flash flooding. Mm-hmm. And we have to do something about it. Mm-hmm. And this is really part of a much larger global picture where the weather is becoming more severe around the world. Severer flooding, longer droughts, longer cold spell like we got this in winter, and I'm sure we'll want to talk a bit more about that in a bit. They're all part of a global pattern. It's not just something that's happening here for us in Vermont. It's something that is affecting the whole global weather in the Northern Hemisphere.
Is it affecting the different geographical areas equally, or is it more severe like down in the equator or up near the poles?
Well, I could give you an example, but it's kind of complicated. Look at what we have. We in the eastern United States had a severe cold winter with cold air poured down into the Midwest from Canada and from the north for several months. Yep. And the pattern stayed frozen in place.
Polar vortex, the first time I've heard that term.
Polar vortex was the jargon. Yes. That was the new jargon. But that was part of a global frozen pattern. At the same time, California had drought, high temperatures, record temperatures in California for January, February, March, and up in Alaska, high temperatures. And downstream of us, it was cold in the United States and a warm Gulf Stream. The jet stream intensified, and storm after storm developed in the Atlantic. And Britain had flood after flood after flood. So much so that in March, the British Met Office, their weather service, had an emergency meeting. They summoned all their chief scientists and said, we have to explain to the public why we've had such extreme weather. Sure. And they tracked all the things that were going on in the Northern Hemisphere last winter. And in their view, and I've just seen it published in Nature, I think, last week, the original trigger was the very warm water in the Western Pacific. You may remember there was a very severe cyclone, Haiyan, that devastated the Philippines. It was in November. And that warm water continued to give lots of storms and cyclones in the Western Pacific. And that sent a train of waves up towards the United States that locked the jet stream in that cold vortex pattern, and downstream gave England tremendous floods. And in Europe, record warm temperatures in the south. So it was a global pattern.
So are we seeing globally warming, or are we seeing just extremes?
We're seeing both. There's a background warming going on, and we are seeing extremes because the global patterns in the Northern Hemisphere are slowing down.
And we're going to run a story in tomorrow's paper, actually. I just grabbed this before I came in today. A report came out that said the United States is warming fastest on its two corners, the Northeast and the Southwest.
Yes.
The Northeast states, led by Maine and Vermont, have gotten the hottest in the last 30 years in annual temperature, gaining 2.5 degrees on average. Why is that? Why the corners?
Well, I think for different reasons. I actually was sent that for comment. I didn't know it was just coming out tomorrow.
It's from the National Climatic Data Center, was the report that came out.
Oh, okay. Well, there's some other people writing reports on it.
Yep,
The Northeast is getting warmest because our winters have been getting warmest. And our winters have been getting warmest because there's this connection of what we call an amplifying feedback between snow cover and temperature.
Okay.
And until this last winter, when it was cold and we were covered with snow for most of the winter, we had been getting less and less snow cover for the last 30 years. And when there's less snow on the ground, less sunlight is reflected and the ground stays warmer. So and that's a very strong effect. It roughly means that our winters have been warming twice as fast as our summers. And so the Northeast has been warming for that reason. I think the Northwest has been warming because of the oceans.
But didn't we have one of the colder winters this winter?
This winter was the exception. The pattern was frozen in place with us getting very cold weather, and the pattern that I was just talking about earlier meant there were record temperatures, warmest in 110 years on the California coast. But if you think back to 2 years ago, 2012, it was exactly the opposite. We had an exceptionally warm winter across not just the United States, but also up into Canada. The 6 months were the warmest on record. And it was Europe, which had very cold, snowy winter that time because the pattern was backwards and frozen, but still frozen in place. So global warming is, in a sense, a misnomer, because what's happening is forced by a whole chain of things which we could talk about in a moment. The climate is being pushed to a warmer state, but the climate system is also quite unstable, so that these patterns are locking in where we see one extreme here and another extreme there, and then the pattern shifts and the extremes move with it.
How do you know what the pattern's going to be for the next year?
Well, that's the problem. We can't forecast it.
Well, you can sort of, no?
No.
I read the Farmer's Almanac.
You read the Farmer's Almanac. For weather forecasting, these are called blocking patterns. And the forecasters, in a sense, are happy when they see one because they know it may stay there for a little while. But if you ask them more carefully, can we forecast those blocking patterns a few weeks ahead of time? And the answer is no, we can't. So it's challenging. We've gone in about 10 years from being able to forecast a few days ahead to a week or so ahead. And in some places like the Southern Hemisphere in Australia, even longer than that, because most of the Southern Hemisphere is oceans. But we can't forecast what it's going to be like next month or next winter or so on. And that's just the way it is.
In the history of the world, have there been parts or times when there's been kind of this same time pattern we're in now, kind of the extremes? Or how unusual is this in
the challenge is that our real records with atmospheric data only go back to World War II, when the first kind of balloons were flown to measure those things. Our records at the surface in the United States go back 100, 115 years. And beyond that, we're looking at tree rings and proxies and corals and cores in the ocean and estimating things on sometimes seasonal, but often only on an annual basis, or back into the ice ages, where much longer timescales, and there were very large changes. But we don't know the details.
What can you find, and what are you looking for? Is it temperature? Is it precipitation? Is it other
When we go back a
metrics?
long time? Well, it depends what you're looking at. Often, if it's, say, a tree, and you look at the ring structure, then they're an indicator of how wet and warm, whether it's a good growing season for the tree that year. You can look at the thickness of it.
Yep, okay.
If you're looking at ice cores, those actually trap bubbles of gas in the cores as they're compressed and turned to ice. So there you can actually see the composition of the atmosphere. That's how we know what carbon dioxide was in the atmosphere going back for the last more than 500,000 years. And there you can see what was in the atmosphere, and you can also estimate the temperature from the isotopes, which are related to when the water was actually evaporated from the ocean. Wow. So yes, those records we have going back, I think, 700,000 years now. So those are quite remarkable. Mm-hmm. And we piece it all together. Mm-hmm. Piece all the bits together from different places, from high in the mountains, from Greenland, from Antarctica. Mm-hmm. And so we can that way look back a long way in time, but not with the kind of detail that you're thinking about when you want to know whether next winter is going to be like last winter. Well, probably.
What matters to me, I'm a skier.
You're a skier. Well, it probably won't be last winter because we're on the cusp, but we still don't know whether it will really happen, of a El Nino in the Pacific. And that's when the Pacific overturns as a whole, and the very warm water that I mentioned gave a lot of storms and very active hurricane tropical cyclones in the western Pacific, shifts towards warm water in the eastern Pacific on the west coast of South America. And when that happens, the whole tropical climate and rainfall patterns shift. Big change. Floods in the Chile and the west coast of South America, and different patterns of drought and rain. And that will probably give us a different winter next year. But we're still waiting to see whether it will really kick in June, July, August this summer.
How do we know if we're dealing with a change or just a cycle of something versus a larger structural change of how things are going to be?
Well, we're dealing with everything. We're dealing with the Earth. Mm-hmm. And the Earth's climate is, you have to realize, it's fundamentally rather unstable. It's cold in the high latitudes at the poles, warm in the tropics where the sun is more nearly overhead, and the weather we see on the planet is moving energy from the tropics to the poles. Mm-hmm. And all these cyclone systems and jet streams that we have are all unstable waves that grow and transport energy. And then on top of that, we're pushing it. We're pushing it with a chain of events. The burning of the fossil fuels in a century or so, which were taken out of the atmosphere 300 million years ago. We call it the Carboniferous period, when we had a tropical hothouse climate on the planet. And that was because there was a lot of carbon dioxide in the atmosphere. And all that was taken down by vegetation, dumped into the oceans, covered over and turned, compressed over hundreds of millions of years, and turned into the fossil fuels, which we discovered. And they drove the whole industrial revolution. Mm-hmm. And we're putting them back into the atmosphere in a century or so, things that were taken out over maybe 100 million years. And so we're giving the system a big push. And the carbon dioxide acts as what we call a greenhouse gas. It stops the Earth cooling as fast to space. Absolutely essential. If we didn't have that in those greenhouse gases, the Earth would just freeze, and we wouldn't have an industrial civilization. But the trouble is there's a chain of events. The CO2 pushes the Earth to a warmer state, and then more water evaporates from the ocean. And water vapor is a strong greenhouse gas, and that roughly triples the effect of the CO2. And then water kicks in, and water has lots and lots of processes. It drives storms, and more evaporation means stronger storms. And the ice on the planet plays another very important role. As it gets warmer, ice melts, like the Arctic ice cap has been melting in the summers. Half of it melted a couple of years ago. And ice reflects a lot of sunlight and sends it back into space. We lose the ice, the oceans absorb it, it gets stored in the ocean, and comes back with the evaporation of more water. Mm-hmm. So this cycle, there's two cycles there. Loss of ice or loss of snow in our winters means that we get warmer winters, and that, if we have on reflective fields, that's a huge effect. And loss of ice on the surface, ice doesn't evaporate. Water, wet ground does. And that water vapor is a strong greenhouse gas. So there's two processes there that amplify things.
Go ahead.
So what's the balance here? I mean, are we in this cycle because it's a cycle, and obviously you say like we're pushing it ahead with all this, carbon monoxide that we're throwing dioxide that we're putting in the air, but can we stop it? Have we gotten past the point of no return, like we've heard from Bill McKibben and some of the other?
Well, We've known for about 40 years now. The first real modern research paper was again from a chief scientist at the British Meteorological Office in 1972. And in the United States, we had National Academy reports in '79 saying and describing quite well what was going to happen. And 1992, we had a global convention meeting, and we drew up the Framework Convention of Climate Change, and all the nations of the world promised they would do something about it. And 22 years have passed, and as you know, some things have happened. We're seeing some transformation in our energy system here in Vermont, but basically we haven't done anything like enough to bring the problem under control.
But if we did do the things that we should do, could it, like, from a climate point of view, could we change it?
Well,
could we reverse the cycle? Are we contributing that much to the problem?
We are contributing a lot to it. But the way to view it at this point is the time scales we think in and the time scales of the Earth are very different.
Right.
The Earth has long time scales. Think at least a generation, children and grandchildren. Really, it's a century or more.
Okay.
So the situation we are now in, it's never too late, because the longer we go on putting more greenhouse gases into the atmosphere, the longer downstream and the much larger the consequences will be in terms of more severe weather by the end of the century.
Okay.
And we can roughly halve the impact at the end of this century if we were to get serious about it this decade. And of course, we've been saying that last decade. We said the same thing in the year 2000, the scientific community did. And that's why you hear from Bill McKibben, it's getting too late. But it's never too late. We will not like what is coming. The Earth will not like what is coming, because it's not just us and our children and our grandchildren and all the people, say, in the tropics who are trying to grow food in a more severe climate. The challenge is for the Earth itself. I mean, there's so much of life on this Earth. We don't know how fast it can adapt. Some things can adapt faster than others, and some things will simply go extinct because we're pushing them faster than they can adapt. And if we slow the process down, we can stretch out the time in which the Earth system and the trees, the forests, and the life in the oceans, all those things can adapt.
What are you seeing as far as the economy of Vermont, how it's affecting the economy of Vermont? I mean, you hear from maple syrup makers and ski industry. How is it changing for them?
The ski industry makes snow. Whenever they can make snow, they make snow. Whenever it's cold enough, they now have much more efficient snow guns, and they have a water supply. So they've been holding it together, and they had a very good winter last winter because of that. Maple syrup, too, has been going up and down. And again, technology, though, has kept it going. Vacuum pumps on the trees have increased the flow of syrup. And so we see some indications, but it has not been really serious yet. And in the long term, the ski industry...
Is that different here in Vermont than in other parts of the country?
People do studies on this. There's a Vermont climate assessment coming out next week from the Gund Institute at UVM. And there's a paper on there on the ski industry. And because the other ski areas further south in New England will lose their snow cover and increase their rain in winter faster than we will, Vermont is going to survive as a ski industry for the next probably 30 years. It's downstream in the century where it gets harder to predict, because we'll get more rain and snow in winter, and those critical Christmas season may disappear. I mean, I garden in Vermont, and I've been digging over my cover crop in January 3 of the last 6 winters. And those winters were winters when the ski industry really didn't have natural snow by Christmas.
So what do we have most to fear in Vermont? Is it floods?
Floods are a big problem for us. The whole of the Northeast has been increasing in severity of they call them heavy downpours. They mean the days on which the upper 1% of the heavy rain falls. And that's increased about 60% in the last 50 years across the whole of the Northeast. So you will see plans from the Agency of Natural Resources, mapping out strategies to protect our floodplains, to protect our forests, because intact forests on the hills mean much less runoff. We had to reforest Vermont in the 30s after severe floods because we had cut a lot of the forest cover, and we had a lot of very severe floods. Water just ran off the mountains. So we're going to have to protect our forest cover, we're going to have to move out of the floodplains, and we're going to have to pay a lot more attention to what can wash off in our rivers. I'm involved in a project at Lake Champlain dealing with the pollution of Lake Champlain from runoff, from farms, from urban areas, and from just erosion of our river banks. And the problem for Lake Champlain is fertilizers. Nitrogen, phosphorus, particularly phosphorus. More of it is in the lake, and the temperature of the lake is going up, and that means more toxic blooms of algae, which are bad for the water quality, and they're bad all around. So I've forgotten what the question was.
The question was, we have to fear. So
it's not a question of what we fear, it's a question of what we have to do.
Yeah.
And
well,
so
your flooding leads to all these other...
Flooding leads to all lots of consequences. So we have to think about it, we have to manage, we have to plan for, we have to build more of our urban structure to store water, to make it go in the ground as opposed to just run off rapidly. And little things. When you put your lawn fertilizer on your lawn, remember it's going to wash off into the Otter Creek, end up in Lake Champlain. Is it a good idea? Mm-hmm. A mulching lawnmower is probably a much better idea than putting phosphorus and nitrogen fertilizer on your lawn. But our society has to rethink essentially all our waste streams. I walk down to the covered bridge in Pittsford every morning, and I look at all the stuff that is thrown out of car windows into the floodplain of the Otter Creek. And I know that it will end up in the lake. Eventually it'll end up in the oceans if it is not biodegradable. And the oceans are just filling up with plastic stuff and junk.
So what do we have to look forward to here in Vermont? We had tornado warning. Are we going to have a hurricane warning? Are we going to have...
Well, we've had 3 East Coast hurricanes in 3 years. The first one nobody noticed. It was Hurricane Igor, and it devastated Newfoundland. It just missed our coast. That was in 2010. Then we had Tropical Storm Irene that came in a whole summer where we had a storms in the spring that raised the level of Lake Champlain to 103 feet for 2 months, well, above flood stage for 2 months, and wet most of the summer in much of Vermont. And then along came it was tropical storm by the time it hit land, Irene, and when it dumped 6-7 inches of rain on wet ground, devastating floods. And then the year after, Hurricane Sandy came up the East Coast, and it combined with another deep jet stream pattern, very much like the winter vortex, except it was in the summer, and it was in the fall. Actually, it was in the late summer. I think it was the end of August. When was
Irene?
No, Sandy.
I believe it was early September, I think.
Yeah, it was around that time.
Yeah,
but what that had was a very big and very powerful system, and very strong winds that drove a 10, 12-foot storm surge that flooded, of course, the tunnels of Manhattan and devastated the New Jersey shore. Yeah. So 3 years in a row, we have had cyclones go up the East Coast.
But how about into Vermont?
Vermont, well, we're a little place.
Yeah.
The chances, we don't know. We don't know when the next one will be. But we would be wise to be ready. Ready in terms of disaster preparedness, ready in terms of having done what we could to protect our buildings and move where we can out of the floodplain. We only get these warnings occasionally. I'll give you an example. The tropical storm Sandy came within 1 foot of flooding the subway tunnels in New York City. They set out a contract. They started to think about it. They designed blow-up plugs for those tunnels, but they didn't install them. They thought they had a long time to wait. And 1 year later, instead of if they had spent a few $1 million plugging those subway tunnels, building those plugs for the subway tunnels, just like inflatable airbags essentially, they would have saved $20 billion in damage. And that's the kind of mentality we have to start thinking about. Is all your important infrastructure out of flood reach?
So are you seeing people do this? Maybe they didn't do it before the storm, but are they doing it after?
some of it's going on in New York City. All the infrastructure, electrical infrastructure that was in the basements is being moved up to higher levels. They're thinking about, shall we spend, you know, $20–30 billion on barriers in the rivers and in the bay there? But I doubt if that's going to happen.
It seems like we still see people building in floodplains in those areas.
People still, well, we have a
FEMA even bails them out, right?
FEMA bails them out.
To rebuild.
Then we were going to put up the cost of the floodplain insurance to more realistic levels, but Congress has deferred it because it's unpopular. So yes, we're doing all sorts of things that make no sense. And if you go down the East Coast in places like Virginia, where the political climate says climate change is not going to happen, we can just ignore it. They've been trying to pass laws, I don't know their present state, that say that you cannot do your coastal planning allowing for the sea level rise that is likely to happen this century. It might affect property values. Well, this is absurd. Absolutely absurd. It should be affecting property values because we're going to expect several feet of sea level rise this century. And every month, some new report comes out. One came out just a couple of weeks ago saying we now see the instability of the Antarctic glaciers looks like it's irreversible. But it's not going to happen overnight. It's probably going to happen 200 years from now. But when it happens, sea level will come up a lot. I think 7 feet.
Which would put some big population
centers. A lot
centers
of population centers
underwater,
essentially, yes.
Including like Wall Street.
And that's, yes, including Wall Street. So the frame of there are two issues here. One is, can we move our society away from fossil fuels towards a much more efficient society? That means going through our housing stock, retrofitting it all so it only costs you half as much to heat it in winter and drops the amount of oil we burn. And then we can maybe move to heat pumps, which are electrically driven, coupled to a solar industry. Are we going to buy more efficient cars or go on buying 20-mile-per-gallon trucks and SUVs and drive one person around them in Vermont when we can buy hybrid vehicles that get 50 miles to a gallon? Are we going to do
public transit?
Or public transit. We're seeing some improvement coming in next week. Are we going to make our society more efficient so that we can then move to a renewable energy economy? And we're starting in Vermont to put some of those pieces in place. I mean, the campaign that's being run against the new coal-fired power plant standards that were released on Monday, this is being called a war on coal. Well, the big drop of employment in the coal industry happened during the Reagan and George H. Bush administration, none in the last 5 years. And now twice as many people are employed in the solar industry than in the coal industry. And that's the type of transformation that is going to go, and we should just run with it because we're on the beginning of it. We need electricity. We need electricity to drive heat pumps. We need it to drive electric cars. People are putting in storage systems and developing those. We've never had those for electricity before. And we're developing the technology to use electricity to make liquid fuels that we need, of course, for transportation. We don't have that yet, but by 2020 we probably will.
So we just have about 30 seconds left. What is the one thing people can do to help be aware of this situation, I guess? Or what should I be doing if I'm watching the show and I'm concerned about the weather? What should I be doing?
Start realizing that we are responsible for the future. We're responsible for our children's future and our grandchildren's future. And we know what to do technically in terms of transforming our society, one more efficient and one based on renewables. So it's now essentially become a moral issue. Are we going to do what is necessary in order to preserve the Earth downstream?
Great. Well, Dr. Betts, thanks for joining us today. And Polly Lynn from the Mountain Times.
It's a pleasure.
Thanks, Polly. And I'm Alan Keays. Thanks for watching Insight.